welcome to Geology and Geotechnical Engineering presentations. Today I'm going to discuss the origin of the chemical elements as an introduction to the coming presentation dealing with the geological time scale. Now, the historic development of the idea of the building blocks of the matters started with the Greek philosopher Aristotle around 300 BC. He supposed that matters or the substance that makes matters comes from four elements or five elements, which are the wind, fire, earth, or water. And anything is not belonging of these four, it will surely be belong to the ether, which is the stars and the planet outside the Earth atmosphere. So Aristotle supposed that the substance that makes matter are five, and his idea dominated the scientific society in around 1700 years until the time of the European Renaissance, and then the scientists believed that his idea is not anymore relative to explain the phenomena happens at the surface of the Earth. Now, our modern understanding to the substance that making the matters is quite different, and we believe that the matters are made of atoms, and atoms are made of three major subatomic particles, which are the protons, the neutrons, and the electrons. And the relationship between these three subatomic particles is that the protons and neutrons are compiled in the nucleus of the atom, and the electron flying in shells around the nucleus of the atom. And now, regarding the protons are the subatomic particles, positive electric charge. One or more protons are presented in the nucleus of the atom. The number of protons in the nucleus is referred to the atomic number, and each chemical element has a unique number of protons. Each element has its own unique atomic number. Therefore, the Mendeleev element periodic chart is organized by the atomic numbers of the chemical elements. The protons within the nucleus of the atom are repelled by the long-range electromagnetic forces. Now, regarding the neutrons are also subatomic particles, not positive nor negative charged. They are neutral. If number of neutrons in the atom differ from the number of the protons in the same atom, the atom will call the isotope of the chemical element. The nuclear force bind the neutrons closely together inside the atom and inside the nucleus of the atom. The neutrons are produced by nuclear fission processes. These processes happens to the chemical elements during its creation time. And they are contributor to the process of nucleosynthesis of the chemical elements. And the last subparticle in the atom is the electrons, and the electrons are also subatomic particles. They are negative electrically charged. Electron contributes to produce several processes we are using today, just like the electricity, the magnetism, the thermal conductivity, and the gravitational electromagnetic, and also the electronic microscope, and few other processes we use electron to produce that. It has a surrounding electric field, and therefore it generates a magnetic field during its motion. And the electromagnetic field produced from other sources will affect the motion of the electron inside the atom of the element. Now, the planet Earth has had a few phases of creation, and we could summarize these phases in 5 phases, in fact, which are the creation of the first 3 elements according to the Big Bang theory. And for those who are curious, please review our presentation regarding the Big Bang, and also the presentation regarding the creation of our solar system. And the second phase is the evolution of the low mass star, and the third which is the process that create the solar system, in fact, and also the planets in the solar system, which is the evolution of the giant high mass stars. And the fourth process, or the fourth phase, is the nebula creation, or the explosion of the stars. And this explosion usually called the supernova. And in the fifth process or phase is the gathering of many meteorites and also asteroids together to create the planet. And this has been explained by the nebula hypothesis, which we are going to discuss it shortly in this presentation. Now, regarding the first stage or phase of creation, the planet Earth, we should start with the creation of the first 3 chemical elements, and that been explained by the theory or hypothesis of the Big Bang. The heavy atoms from hydrogen are its isotopes, and the atom of the hydrogen usually calls the protium, and other isotopes of the hydrogen calls the deuterium and the tritium. So we have some isotopes from the atom hydrogen or the element hydrogen that was the building blocks of the matter of the universe. The deuterium, which is an isotope of the hydrogen, composes from one proton and one neutron inside the nucleus of the atom of the hydrogen, and there is still one electron flying around the nucleus of the atom, while the nucleus of the hydrogen, when one neutron more added to the number of the proton and the neutron inside the nucleus of the atom, then the other heavy isotope of the hydrogen appears, which is the tritium. The tritium has three subparticles inside the nucleus of the atom, which are the two neutrons and one protons. And then to understand the number of the neutrons inside the nuclear, we should subtract the number of the atomic mass from the atomic number. Then we will have the number of the neutrons inside the atom. Here we have three subparticles inside the nuclear of the hydrogen, two neutrons and one proton, which is the isotope of the hydrogen. In the written language, we write the three subparticles in the top of the represented symbol of the elements, and the number of proton and the electron down from that. So the number one is represent the numbers of the electron and the proton inside the atom, and while the 3 is representing the subparticles inside the nucleus of the atom, which are the two neutrons and one proton. So in the other side, the representation for such a chemical reaction is that the deuterium, which is here, it is fused with one neutron, and it will become and would appear as a heavy element of the hydrogen, which is the tritium. And the tritium itself will gather with one proton more to be and one neutron more, of course, and in this case we will have two protons and four neutrons inside the two protons and two neutrons inside the nucleus of the atom, and the total number of the subparticles inside the nucleus of the particles here, nucleus of the atom here is now 4, and there are still two electrons flying in the first shield of the nuclear of the atom. So we have the now the created the first and the second chemical element, which are the hydrogen and the helium, which are the base for creation all other elements in the chemical periodic chart of Mendeleev. So here the reaction continues to make the third element, which is the atom of the helium that fuse with the atom of the hydrogen 3 or the tritium to appear as a new atom, and this is the atom of lithium according to the periodic charge. Here in the atom of lithium, number 7 is indicating that there are 7 subparticles inside the nucleus of the atom. 3 of them are protons and 3 electrons, of course, and the rest of the 3, which is 4, are the number of the neutron inside the nucleus of the atom. The lithium is an unstable element and can be disappeared when it has been created at once. So this reaction shuts down for a period of time 380,000 years, and then after this period the temperature was still hot enough to the gases to be gathered to make the galaxies. Second phase of creation of the planet Earth starts with the evolution of low mass stars, and stars are a giant reactor of elements consisting of core, of course, inside in the center of the star, and inside the core it is reactive and convection zones. The gases being compressed at the center of the star, which is the core of the star. The two nuclear reaction happens inside the core, which is the fusion of the creation of the or production of the chemical elements, and the fusion processes, which is the creation of the neutrons. And fusion is the simply the the atoms collide together to produce light, and the fission is the reverse process where the light collide to produce subatomic particles and elements. The core of the stars, for example, our sun, is hot enough to collide protons to build up heavier elements producing gamma ray as a result of the fusion of the elements, and the result is light coming out from as an energy, of course, coming out from these type of colliding atoms. Our sun, for example, is consisting of hydrogen 75% and helium 25%, and all other gases composes just 1% of the size of the star. The stars has a time of birth, and they have also a time of death. So in the period of the living stars, the hydrogen inside the core began to be hot enough to make a nuclear reactor inside the star, and these processes happens to produce helium from the hydrogen. And when these processes, when there is no more hydrogen, the stars began to be a red giant, and in case of our sun, it will extend in size to reach the domain of the planet Jupiter, and then it will explode. And in this type of or in this stage, the elements hydrogen and helium will give us a few other elements, just like the lithium, the beryllium, the boron, carbon, nitrogen, and oxygen, and not too much fluorine. So the reactor shuts down, and the stars become an nebula. So this is the process of the evolution of the low mass star, just like our sun. Evolution of the our Earth is comes from the evolution of the giant high mass stars. These stars are many times bigger, many thousands times bigger than the size of our suns, and containing more gases and atoms. And these stars, of course, are there is inside the star a type of balance between the nuclear reactions inside the core and the gravity outside the domain of the star, which is the gravity of the space. Gravitational attractions between the space bodies. The pressure is coming out from the reaction inside the core of the star. At the end, the gravity wins because it's stronger and more dominated in the space, and the core of the star began to shrink and explode, resulting supernova and nebula. And this type of nebula is not like the low star mass containing more elements. In fact, the rest elements of the periodic chart. So before the supernova, the core of the high mass star began to convert hydrogen to helium and beryllium, boron, carbon, nitrogen, oxygen, and so on to fluorine and neon and natrium, magnesium, aluminum, silicon, phosphate, sulfur, chlor, and argon, and potassium, calcium, cesium, titanium, vanadium, cerium, manganese, and the last is the element of iron. The iron is the most stable element in the universe, and the star cannot produce more elements here, because the stability of the atom of the metal iron needs energy to be fused to make the rest of the elements of the periodic table or periodic chart. Therefore, the core began to shrink again together, and the gravity make a balance to the these forces, pressure forces inside the core, and the result is an explosion in a type of nebula. So the atom of iron has an atomic mass of 56, is a stable element and the most stable elements in the universe. The star needs to continue the conversation of the processing, making the rest of the element, but it's need energy to make such processes which the star does not have such energy. And the nuclear reaction of the giant high mass star shuts down, and the result is a supernova. Here, the giant star does not develop to a black hole, but to a nebula of gases, mostly oxygen, helium, hydrogen, and the rest of the elements of the periodic charge. And this will be surrounding by the asteroid meteoroids composed of the chemical element of the periodic chart, chemical periodic chart elements. So the chemical reactions happen there is the base starts from the helium, which is an isotope of the hydrogen, and continues to make the rest of the elements until the oxygen, the neon, and carbon, and magnesium, silicon, and each every time new elements appear, add light or photons also being added out from the star. So these processes of fusion processes to make elements continues until it's reached the most stable elements in the universe, which is the iron. Then an explosion happened to the giant high mass star, and the rest of the chemical elements appear due to that. Just to explain how the chemical elements of the periodic table appeared, is that in the first step, the Big Bang gave us three major elements, and then the explosion of the low mass stars give us 8 elements and nothing more, and a nebula happened from that type of explosion. And when we are speaking about the giant high mass star, the core of the star, the nuclear reactive of the star can make fewer chemical elements, and until it's reached the most stable elements in the universe, which is the iron, and then an explosion happened, and the supernova producing a nebula which contains all the rest elements of the periodic chart. Now, the fifth stage or phase of creation of the solid planet, and one of them is the planet Earth, is the meteorites and asteroids gather together to make a bolt of fire, which in the evolution of this bolt of fire will become a planet orbiting the sun. And this has been explained according to the nebula hypothesis. Here we have a visualization shows the processes of the evolution of the nebula to a solar system. Here starts the explosion of the giant mass star, and these will be in steps to make a solar system from the explosion of the high mass or giant high mass star. This will make a nebula, which is a solar nebula containing uneven distributed gases, which this nebula, because of the gravity, can attract together and make a accretion disk, and the material inside the disk, when it is spin in one direction, becomes to move to the center of the of this disk, and then a new star, a low mass star, appear in the center of the nebula, and this we call it the protostar, which according to the evolution of the nebula or the solar system can also attract the asteroid of the heavy metals to be collected together and making a bolt of fire, or we call them usually the protoplanet, which the Earth as a planet is being created in this according to these processes. So the stars of the nebula or of the solar system can also be distributed according to their mass and according to their size and the content of the planet. The terrestrial solid planets are near to the sun, and the gaseous planet are far away from the sun. The gaseous planet usually acts as a vacuum to all the cosmic dust and collect it to one giant gas star. I think now it is obvious that the submatter or the substance that making the building block of the matter are the chemical elements, and the chemical elements are of course coming out from the atoms that the universe produced it in the beginning of the Big Bang explosion. Our planet Earth is a result of a giant high mass star explosion. The explosion causes supernova and produce a nebula. The nebula contains of all the chemical elements of the periodic chart and evolves to an accretion disk and a newborn sun, which is the protosun, and planets out from the gathering of the solid part of the materials out from the explosion nebula, and these planets orbiting according to the physical laws around the huge star or the proto-sun. The asteroid built between the terrestrials and the gas giants contains the remains of the solid bodies and the nebula evolution. The giant gas planets of our solar system act as a vacuum or for small solar bodies and balancing at the same time the gravity of our sun. The chemical elements, all things, animals, trees, planet cover, light and the darkness, which is the antimatter around us, are made of atoms. Even me and you, we are also made of atoms. The day we are not anymore exist here in this universe, our atom will return to the planet Earth, and the day the planet Earth is not here in the universe, the elements will return to the universe to be recycled, and this process, we call it usually the reincarnation or the rebirth of the matter. Our bodies composes mostly from element oxygen, and the percentage of oxygen in our body is 65. 18.5% is carbon, 9.5% is hydrogen, 3.3% is nitrogen, 1.5% is calcium, and phosphor takes just 1%, and the rest of the elements are less than 1%. Well, I would like to thank you for watching this presentation for today. And my name is Sabah. I am engineer geologist, and my coming presentation will be will deal about the geological time scale. This presentation is an introduction to understand the principles of the divisions, time divisions of the geological time scale. Well, thank you again for watching this video, and please give us a thumb up, like, share this video for your friends, and subscribe. This will help us to continue producing such a presentation. Thanks indeed for watching, and take care.